All right. Yes. So, g'day everybody. So my name's Callan Fox. I work with Kaushik in product management for the unstructured division. And yeah, today I'm going to cover simplicity at any scale and what that means. I'm pretty much going to talk about what PowerScale can do today and why that's important for customers. Okay, so obviously PowerScale OneFS takes the OneFS that's been tried in the market. It's been around in many industries and it's been tested. And then we've done a lot of work, and Kaushik's already sort of gone over a lot of this, but we've done a lot of work to decouple the reliance on the hardware. And that wasn't a small thing to do. Like, there was a lot of things that we used to have to rely on. There was a lot of changes that we had to make and optimizations in the way our journals work. Optimizations to actually take advantage of generic platforms, and the way that, when an actual OneFS used to be effectively prescribed what its underlying hardware was, we had to make that a lot more flexible. So later on, Kaushik will talk a little bit more about what that means as far as an ongoing journey and where we're going to take that. But today I'm just going to just go over sort of the features of PowerScale OneFS. So what I want to just quickly just make really simple is that, so PowerScale OneFS really has three components. And what is really important is, as we start to decouple the hardware and the software more, it's quite important to a lot of our customers that the actual software contains everything they need. And that's effectively what I'm trying to show here, right? So we've got the file system that we've already talked about a little bit. So single scale out, single file system, single namespace, node-based. And then we've got the operating system, which ties everything together. There's a lot of optimizations made there around, if a system has certain amounts of memory or whatever, how it tunes itself to take the most advantage of the system resources it's got. And then there's all the data services and the data protocol access and everything today. And really, this is what gives us the ability to have and give all the features that you come to know, the scalability, how auto balance works, all the resiliency. What I'm basically going to do for the rest of these slides, I don't have a lot of slides today. We're trying to keep it quite light because, just to enable some questions and get onto some other stuff. But what I will go through is just some examples of what that looks like. So what I want to do first is just go over the benefits. What do we mean by simplicity at scale, and what does that give us? So the first benefit is, automatic balancing of data. So some of the architectures that we sometimes get compared to, they'll take traditional constructs and they'll stitch them all together and then they'll lay data out on top of it. And what that can create is it can create a management challenge. It can create a challenge where you need to, you create hotspots in the way your data is written. Some components are busier than others. Due to the way we have a node-based architecture and the way we write data across all the different media, I'll say media in the system because obviously, it's, the days of spinning drives are sort of like slowly going away. What that will mean is that we can see, we can lay the data out and it's quite spread from day one. So that's the data side of it. The second side of it is, because we're node-based, we really need to have elasticity. So what that means is we can either grow from really small to really big, we can shrink, we can dynamically change. And that really comes down to like a customer being able to use, change the cluster to suit their business needs. We'll have customers that will start off with a node-based solution of a certain size, and they may need to split that cluster in half and then, move it to another side or something. We can do all sorts of things like that with the elasticity.
So when you talk about automatic balancing and you're talking about capacity, I can see what you mean by that. But what about front-end connectivity and managing and balancing user requests that are coming into the system and requesting data? How much automatic balancing are you doing of that side of the art?
Yep, so I'll have a slide on that, but yes, so that counts it as well. There is another benefit that I'll talk to very shortly that goes into the actual connection of clients themselves. But again, That's all totally handled by the system. So, you just, everything's policy based. You set up a policy and or take the default in most cases, and we will lay out the clients in the same sort of fashion, for the best performance we can get at the time.
Okay, so just to qualify, you're talking about dynamic connections as well. So as users connect and disconnect, You're not going to get people going through a single node, or you're not going to get a node overloaded if that particular workload is more demanded through one particular node than another.
So yeah, so when as connections, depending on the connection type, are created, they at that point in time are connected to a given node, and we do have the ability to move those connections between nodes as needed. It just comes down to the type of connection, be it certain protocols of NFS versus certain protocols of SMB. But yes, that's correct.
Okay.
Okay, so I'll continue on, and then we'll get to some of these, and I've got a couple of examples just to show some visual examples. So data efficiency, obviously, we've got really good data efficiency story just by the way we lay out our data. As you add more nodes, we get more and more efficient. But we also have inline data reduction. So inline compression, inline deduplication are all standard with PowerEdge nodes, and we'll talk about that again shortly. Resiliency, so this is sort of what Chris was talking about. When we want to lay out our cluster, both from a front-end client perspective and from a data perspective, we do it in such a way that we can tolerate a certain amount of failures that the customers want for their data. And again, given that we're not a system that's based on traditional constructs, you can change it on the fly. So if you want to go from one node of protection to 4 nodes to protection, we can do all of that on the fly without having to re-migrate the data and reset everything up.
Callan, sorry, it's Enrique here. What do you mean with up to 85% of storage utilization? You mean before inline compression and duplication, but after RIDE or Erasure coding, or? No,
so that effectively means and there's a little reference down the bottom there. So I kept it the same as what's in that document. But that means of the raw capacity, how much of it you can effectively use. And then on top of that, you can have data reduction based on your workload, which obviously varies heavily based on what the workload is. Some customers will get virtually none. Others will get quite a fair bit.
And do you support the compression and the duplication, or just one of the two?
No, both separately, or both together, I should say.
Together, okay.
Yeah, and I'll have a slide on that. I'll cover a little bit more detail on what that looks like.
Okay, thank you.
So then we've got the unified access. This is one of the most important things. So one of the big changes we made with PowerScale was we brought in AWS S3, and we didn't just bring it in as a protocol that sits there on its own little separate island. It is multi-protocol aware. So what that means is you can write data in over NFS and pull it out over S3. The main benefit, or the main use case we see customers wanting to use there, is the sort of bridging type scenario. You can imagine that customers have got a lot of legacy applications out there, or they've got collection systems that are running using, say, NFS or SMB, and they want to write data, but then they've got new age college students that learnt everything based on S3. So they want to consume that data based on using the S3 protocol. So we allow that. Sorry, go ahead.
Yeah, so you have file and object parity, which is great, but most of the implementation have to deal with differences between file system and objects. So, for example, file versioning or file locking and things like that. So, how do you manage all of these differences between the two?
Yeah, so under the hood at the moment in this implementation, we're POSIX based. So effectively the objects are written as files, and there's obviously some limitations around there. So for example, S3 can have a backslash in a file name, but a file system obviously can't, right? That would delimitate a different directory. So there are some caveats, but it's very limited. And in the testing we've had so far, it doesn't seem to make too much of a difference to actual most workloads. Now, as far as how do we handle stuff like versioning, in our initial implementation, we'll be using the snapshotting functionality of PowerScale OneFS, the actual underlying file system itself, to provide that. But we do have a lot of roadmap items for S3 around offering more and more functionality in the actual API head itself. And again, I'll have a little more on that shortly. So, and then obviously simple to manage. So everything has to be simple to manage, and there's a lot of times we need to get there around DevOps, and we have API management, for example, say something like Ansible that we've released.
So back to unified access. Does that include HDFS and those sorts of things?
Yeah.
So it's NFS, SMB, S3, HDFS. What else?
So you
FTP, I'm sure.
Yes, there are. Yeah, that's right. And then Swift technically, but Swift is more its own separate thing. It doesn't. Okay. It doesn't actually go to the multi-protocol story. Right, and its adoption is less and less anyway. So all right. So what I'll do is I'll just quickly cover these, and I'll keep the time. So this is just a quick example of as data comes in, the PowerScale nodes fill up, and then at a certain point in time, you can actually expand. You can add a node, and then an automatic process will expand the cluster and the file system across those nodes, and then optimize them.
So somebody mentioned on the Twitter stream that the old Isilon nodes used to have, I think it's NVDIMMs or NVRAM kinds of things. Yep. And the new servers that you're allowed to support, do they also have NVDIMM types of requirements?
Yeah, so how it worked is, so Generation 5 Isilon had NVRAM journal cards. Gen 6 had memory that we would mirror between two paired nodes. That's why they came in twos. PowerEdge nodes have, NVDIMMs. So the first, there's not all the DIMMs, but some of the DIMMs are NV enabled, which means they're non-volatile, and that's what we use for our protected journal.
So the new servers would require that technology.
That would effectively be, at this point in time, that's effectively one of the requirements for us installing PowerScale.
All right, thanks.
So then Chris, I believe, asked a question about this. So, we have ability to, as nodes or as clients come in, we can look at all the cluster nodes, know how busy each of them are, and then we can service the connection based on the node that makes sense at the time. And obviously there's some dynamicness that we can do there. When there's things like node failures, or it might even not be a node failure, it might just be a front-end network failure, but we have a requirement to move those connections. We can shift the connections. Depending on the type, we're aware of what the protocol will support. So that might mean that we drop the connection. It might mean that we move the underlying IP that the connection connects to. It just depends on the types of clients that we're dealing with, and we can work that out at the time. As far as elasticity, what other examples does that give us? What other use cases does that give us? It gives us the ability to do no migrations. So obviously a lot of customers out there today have, these legacy systems that they build, and there's a point in time where a 5-year, 3-year mark, whatever it is, and you need to lift and shift all that data to a new platform. And then there's a migration associated with that. Migrations have obviously gotten better over time, but there's still risk and, downtime and disruption, everything associated with that. So what we can do is we could take, for example, these Isilon nodes, so Gen 6 Isilon nodes, we could add in new PowerEdge PowerScale nodes, and then what we could do is we could tell the system to dynamically and transparently move the data to the new nodes. These nodes are denser in terms of capacity and performance, so you're most likely going to get some sort of savings there around, going to smaller nodes or less nodes, depending on your use case or what you're trying to do. So after this is done, we can get back to the state of us being in a situation where we've just gone to the new nodes and the old ones are gone, and we didn't have to worry about any disruptions or anything to the client base.
So, Callan, this is this image kind of reckons the question on pricing and structure. I understand the appliance model, minimum 11 terabytes a cluster, but if I'm bringing my own servers, PowerEdge servers are pretty dense when it comes to capacity. So how are you charging based on a bring your own storage or server model?
Yeah, so I might let Kaushik answer that. He's got a section a little bit later on where he's going to cover the the roadmap of what we're doing as far as making. So I just want to make it clear. So today, we don't allow someone to install PowerScale on just any server. There's going to be a roadmap for that. Kaushik will cover that. And there's some pricing and some data associated with that as far as these nodes. So I might let him answer that question when we get to that.
So we today charge it on a per terabyte basis. As you rightly point out, our smallest PowerEdge server is 11 terabyte with 4 drives, but we have pretty dense PowerEdge servers. So that's why our pricing is basically based on a tier as well as on a per terabyte basis for the software.
To understand better, so if you charge for terabyte, what happens if I have all NVMe devices and a small cluster and not a large cluster?
That's correct. So what we do is we have different tiers and per capacity. So for example, a per terabyte of NVMe will be very different from a per terabyte of for nearline SAS, right? So the per terabyte rate is different if it's HDD versus NVMe.
All right. Well, I'll continue on, and we can keep. If any other questions come up, we can get to those. So data reduction. Just want to quickly cover what we've already spoken a little bit about this. Obviously, we have inline data reduction, so that means inline compression and dedupe. So what it effectively means is the data comes in. The first step is a zero to text. So in other words, if you're writing, just all zeros, the first thing.
Callan,
yes.
Some of the other power solutions offer a guaranteed data reduction level. Is that something that PowerScale does as well?
Yeah. Let me chime in out here, Callan, if that's okay. Yes. Yeah. So all our power products are part of the future-proof guarantee.
Yeah.
And as part of the future-proof guarantee, we offer a slew of assurances, and including the data reduction guarantee as well.
Okay. Thanks.
Cool. Yeah. So inline will basically detect, zero detect. And then we will do inline compression and dedupe. Separate to that, we also have legacy systems. Some systems may not want to do that for whatever reason. There might be a specific use case. We can still do post-process dedupe, but the main thing that I wanted to talk about here was the post-process file packing. So for files that are really, really tiny, like there might be 10, 20 bytes or whatever they are, or up to even larger than that, we can take those files and we can pack them into a larger container, all hidden underneath the hood as far as the file system is concerned. The user doesn't know any different. And then we can data protect that entire chunk. So it's very, very, very efficient. And that's how we get a lot of savings when it comes to small
And what's a typical data protection? And you mentioned 1 to 4 parity or node or drive failures. I mean, is it a standard RAID or erasure coding or? Yeah,
so we use Reed-Solomon erasure coding, and the default protection, obviously it varies. The system automatically tells you if you get up to certain nodes, hey, you should probably change this. But the standard protection is to protect against 2 drives or the failure of an entire node. And those 2 drives are within each. Sort of like under the hood, we have these failure domains. We split the cluster up to make, to improve availability and all sorts of other things. It's per each of those. So yeah, so 2 drives and 1 node is the default.
Good, thanks.
Yeah, I mean, there's white papers online if you want to know more. There's a lot of collateral that's getting released with PowerScale to cover all of that. Okay, and then I haven't got that many more slides, and then I'm done. So, automated data tiering, very powerful, very important. A customer can have a cluster that consists of multi-generational, or it might have different types of nodes. And what we can do is we can have these policies that move data. So, for example, you might have a policy after 1 week, it moves down to a hybrid tier for lower cost, and then maybe down to an archive tier over a month. And obviously, we're just being very simple here. It can move up and down. You can move it based on lots of different other aspects of tiering. We're doing a lot of work here. The other thing we can do is we can extend this to the private or public cloud from an object perspective. So a customer might have an object investment, or they might want to utilize the public cloud. We can also tier off to that as well. Again, this is all completely seamless. I'll cover a little bit about what Data IQ can do, but this is the transparent way to tier data from a user perspective.
Excuse me, Callan. Again, on the licensing, all of this is included in the basic license, because at the beginning you told us that it was only on a terabyte basis, right?
So this isn't so each of the features are still licensed separately, and
yeah. So let me clarify that. So there we have two options. You can buy we have 3 different bundles. You can buy the basic, and then you can buy any of the software a la carte. And then we also have an all-inclusive. So basically, you buy that all-inclusive, and that includes all the software, right? So when I was talking about it, I was meaning the all-inclusive version, which is typically what we use.
Yeah, and our account teams will help at the time when it comes to work out what's best for the customer. And then all I'm just trying to show here is that, we can obviously still specifically say at a project level, hey, I want that project to only go to the archive pool. There's a lot of other stuff that we don't even talk about because we just don't have time to go into the details, but we have APIs that are exposed where you can say, I want to tier that file down or up. I want to know that directory, what percentage of each of files or data is sitting on my PowerScale versus my archive pool or whatever. We have all that there, and it's all available.
So it brings up the question. I think you mentioned snapshots earlier. Can you snapshot at a file level?
Yes, you can snapshot technically at the file level. Most customers would do a directory level. But yeah.
Okay, thanks.
So unified file object access, really the main point here is, again, the bridging use case. I already talked about it briefly. We have all the data services are available to all of the protocols. There are some slight caveats. So S3 day one, where we're not supporting cloud pools as a back end, but otherwise it's pretty much everything. And then obviously we've got the performance we can offer. So we have all NVMe performance that we can offer to any protocol as well that we bring in with PowerScale. And then this is my last slide, and then I'll hand back to
So one of the key things with respect to scale-out storage like this is metadata, how the metadata is being handled and protected and where it is, and it doesn't become a bottleneck. How is, I don't know if you're going to get to that level of discussion, but where is the metadata in the solution, and how is it protected?
Yeah, so I wasn't going to go down to that level of detail, but I will answer your question. So in terms of of PowerScale, all the PowerScale nodes that we offer today are all flash. So all of the metadata is already stored in all flash. We have a lot of caching algorithms that can be used to cache data, cache metadata. We keep the most hottest metadata in memory, all the things you would expect. You're right in saying that the performance of a file system is generally based on its ability to handle metadata and metadata very effectively, and also be able to scale lots of metadata. So what I mean by that is we dynamically allocate our metadata, so we can have anywhere from tens of files up to tens of billions. Or hundreds of billions. There's no real limit. It just comes down to the space that you've got on the system. If you're running PowerScale on a legacy Isilon node that has hybrid drives, so it has solid state drives as well as normal hard drives, then yes, we have we have technologies where we can cache that on SSD, either hard coded, or it can just dynamically figure out, this bit of metadata needs to live here. We have algorithms that can work all that out. The main thing is trying to make the customer make less decisions about their workload, right? That's where we're going with this. There's a lot of work that we can't cover because we just don't have the time that we've done around making a data set, like features and data services prescribed to a data set more easily. And so the customer shouldn't have to worry about all those little things. That the system should just figure it out, basically. But yes, we have ways to deal with metadata.
So the other question, follow up on that is, does Isilon, I'll call it performance and throughput and that sort of thing, scale with more nodes? Let's say they're all equivalent in size or equivalent, all flash nodes kind of thing.
Yes, so we still talk to linear scale. So the PowerScale nodes today, in fact, there's been almost further optimizations done there. So yes, if you've got nodes of the same type in your example, you get virtually linear growth in terms of performance and capacity. Technically, capacity will actually get better as you get more nodes because the efficiency gets better up to a certain amount where it's kind of diminishing returns past that point.
Okay, thanks.
The performance will definitely scale linearly. Okay, and then really, this is just my final slide, and then I'll hand back over to Kaushik. I'm not going to cover a lot of this anyway, but the point is there's lots of things that we still offer in terms of PowerScale, what it can do, down from everything from snapshots down to, worm functionality, locking files, all the bits around S3 and the various protocols.